All right, so this is our lesson on the laws of probability. First one we're going to look at is the addition law. And the addition law states that for two events, A and B, the probability of A union B, or A or B, they mean the same thing, is equal to the probability of A plus the probability of B minus the probability of A intersects B. So if we write it in words, the probability of either A over B, A or B, is equal to the probability of A plus the probability of B minus the probability of both A and B. And if we look at that in a Venn diagram, it kind of makes sense why that is, because the probability of A or B is equal to all of this. So it's equal to everything in here. So it's equal to the probability of A, if we mark that with red, that's the probability of A, plus the probability of B, which we can mark with blue. And then we have to subtract the probability of the intersection, because here that is counted twice and we only want it counted once. But it was counted with our red, with the probability of A, and it was counted with our blue with the probability of B. So we have to subtract that middle intersection part. So basically we do the probability of A plus the probability of B, and then we're going to minus this part here because we've actually added it twice. Okay, so here's an example. If the probability of A is 0.6, the probability of A union B is 0.7, and the probability of A intersects B is 0.3, then we want to find the probability of B. And if we draw a Venn diagram that kind of represents this, then we have the probability of A here and B here. And we know that the intersection, A plus B, or A and B, is 0.3. And we want to know what's the probability of B altogether. So we need to find this and we need to find this. And the way we're going to do that is our formula before said the probability of A union B is equal to the probability of A plus the probability of B, and then we're going to subtract the probability of the intersection of A and B. So the probability of A union B right here is 0.7, so I'm going to plug that in. 0.7 equals, and then the probability of A is 0.6, plus the probability of B, which we don't know what that is, I'll call that X for now, minus the probability of A intersects B, which is 0.3. So we get 0.7 equals, then 0.6 minus 0.3 is 0.3 plus X. Then we're going to subtract 0.3 from both sides. So that cancels, and we get 0.4 equals X. And X was equal to the probability of B. So the probability of B is equal to 0.4. So here we have mutually exclusive or disjoint events. And mutually exclusive or disjoint events are events that have no intersection. There is no intersection. The probability of A and B is 0. Notice in the Venn diagram, our circles do not intersect at all. So if we don't have any probability of A intersects B, then our formula that was probability of A union B equals the probability of A plus the probability of B minus the probability of A union B. Well, if this right here is 0, then it pretty much goes away. So we no longer need that. So this becomes our new formula. So probability of A union B is equal to the probability of A plus the probability of B, because there is no intersection that we counted twice. So our addition law, if the events are mutually exclusive or disjoint, becomes this right here. So here we have 31 people on a bus tour. 7 were in Scotland, 5 were in Wales, and it says are S and W mutually exclusive events? And since a person cannot be in Scotland and in Wales at the same time, they can only be in one or the other, the answer is yes, they are mutually exclusive. There is no intersection. There are no people on that bus tour that were born in Scotland and were born in Wales, because they can only be born in one or the other. They're mutually exclusive. So then it says, if a member of the tour is chosen at random, find the probability that he or she was born in Scotland. Well, 7 were born in Scotland out of 31 total. So that is the probability that they were born in Scotland. 7 out of 31. The probability that they were born in Wales, there were 5 born in Wales. Total of 31 people. So the probability they were born in Wales is 5 out of 31. So then the probability that they were born in Scotland or Wales would be the probability of S union W would be equal to the probability of S plus the probability of W, and we can leave off the intersection because they're mutually exclusive. So the probability of Scotland is 7 out of 31, plus the probability of Wales is 5 out of 31, so the total is 12 out of 31. So the probability that they were born in Scotland or Wales is 12 out of 31.